The sun has been Earth's best friend for 4.5 billion years. It gave us warmth. It gave us light. It made life possible. But NASA's most advanced artificial intelligence just finished a calculation that took 3 years to complete. And the answer is terrifying. The machine analyzed 400 years of solar observations, 50 years of satellite data, and ran 2.7 billion simulations of our star's future. It calculated the exact timeline of Earth's destruction, down to the specific sequence of events that will end all life on our planet. And here's what's keeping scientists awake at night. The death of Earth won't happen all at once. It will be a slow, agonizing process that begins far sooner than anyone expected. Let me give you the number that sent shockwaves through the scientific community. According to NASA's AI prediction model, Earth will become completely uninhabitable in approximately 1.1 billion years. But that's not the terrifying part. The terrifying part is what happens before that. The AI calculated that within just 500 million years, possibly sooner, the sun's increasing energy output will trigger a catastrophic greenhouse effect that will boil away every ocean on Earth, every lake, every river, every drop of water, gone, evaporated into space. The surface temperature will exceed 150 degrees Celsius. Nothing, and I mean nothing, will survive. Earth will become a second Venus, a hellscape of crushing heat and toxic atmosphere. And the AI identified something even more disturbing. This process has already begun. The countdown started millions of years ago. The sun is getting brighter. 1% every 100 million years. Sounds small, but that tiny increase is a death sentence already signed and sealed. Now, before I reveal the complete timeline of Earth's destruction, and trust me, the details are far more disturbing than you can imagine, I need to tell you why this video is different from anything else you'll watch today. Everything I'm about to share comes directly from peer-reviewed research, NASA data releases, and official scientific projections. This isn't clickbait doom-mongering. This is the actual scientific consensus on our planet's future. On this channel, we break down the most important discoveries in space and science. We turn complex research into stories that actually matter, because understanding our cosmic future isn't just fascinating, it's essential. If you're the kind of person who wants to understand the big questions about existence, about our place in the universe, about what happens next, then hit that subscribe button right now. Turn on notifications, because what I'm about to reveal will change how you see everything. Seriously, the second twist in this video, it might be the most important thing you hear all year. To understand why NASA's AI made this prediction, you need to understand what the sun actually is, and why it's been slowly killing us since the day it was born. The sun is a massive nuclear fusion reactor. At its core, temperatures reach 15 million degrees Celsius. Every single second, it converts 600 million tons of hydrogen into helium, releasing energy equivalent to 400 trillion watts. This process has been happening for 4.6 billion years. And here's the critical thing most people don't understand. As the sun fuses hydrogen into helium, its core becomes denser, and a denser core burns hotter. A hotter core means more energy output. More energy output means a brighter sun. NASA's records show the sun is approximately 30% brighter today than it was when Earth formed. Early Earth received much less solar energy. Scientists call this the faint young sun paradox. How did liquid water exist when the sun was so dim? The answer involves greenhouse gases that kept early Earth warm, but now the equation is reversing. The sun keeps getting brighter, and Earth's natural thermostat can only compensate so much. Eventually, the balance breaks, and NASA's AI calculated exactly when that happens. The AI system, called HELIOS for Heliophysics Enhanced Learning and Integrated Observation System, was developed over 5 years by NASA's Goddard Space Flight Center. It combines solar physics models with climate science, geological history, and stellar evolution data. The goal was simple but ambitious: create the most accurate possible prediction of our sun's future behavior and its effects on Earth. What they discovered was more detailed and more disturbing than anyone anticipated. NASA's AI didn't just predict when Earth will die. It mapped out the entire process, stage by stage, catastrophe by catastrophe. And each stage is worse than the last. Stage 1 begins approximately 250 million years from now. The sun's luminosity will have increased enough to accelerate Earth's carbon cycle. Plants will begin struggling to photosynthesize efficiently. C3 plants, that's about 95% of all plant species including most trees, will start dying off. The AI projects that global forest coverage will decrease by 80%. Only C4 plants, certain grasses and crops, will thrive. The mass extinction of plant life will cascade through every ecosystem. Stage 2 arrives around 400 million years from now. This is when things get catastrophic. The AI calculated that solar radiation will increase enough to break the carbonate-silicate cycle that regulates Earth's temperature. Carbon dioxide levels will crash as weathering accelerates. But here's the twist. This cooling effect will be overwhelmed by the sun's raw heat output. Earth enters a death spiral where nothing can restore balance. Stage 3 is the end of complex life. The AI's models show that within 500 to 600 million years, surface temperatures will exceed the tolerance of almost all multicellular organisms. Mammals will be extinct. Reptiles will be extinct. Fish will boil in warming oceans. Only extremophile bacteria, organisms that can survive in boiling water and extreme conditions, will remain. And even they are on borrowed time. Stage 4 is the evaporation of the oceans. NASA's AI pinpointed this event at approximately 1.1 billion years from now. Though with error margins, it could happen as early as 800 million years. Now let me show you exactly what NASA's AI calculated, because the precision of these predictions is what makes them so unsettling. Helios analyzed 2.7 billion different scenarios, varying solar evolution parameters, Earth's orbital dynamics, atmospheric composition, and dozens of other factors. From all those simulations, it generated probability distributions for each catastrophic threshold. The AI's prediction isn't a single number, it's a range with confidence intervals. Let me break down the key findings. Finding 1. There is a 95% probability that Earth's average surface temperature will exceed 40 degrees Celsius within 300 million years. That's the threshold where human survival without technology becomes impossible. Most mammals can't survive sustained temperatures above 35 degrees with humidity. For context, the hottest wet bulb temperature ever recorded on Earth was around 35 degrees Celsius. That's the limit where the human body cannot cool itself through sweating. Above that, you die within hours. Finding 2. The AI calculates an 87% probability that the last naturally occurring liquid water on Earth's surface will disappear between 1.0 and 1.3 billion years from now. The median estimate is 1.1 billion years. Finding 3, and this is the one that really disturbed the research team. The AI identified periods of accelerated warming that weren't predicted by simpler models. There are specific intervals where multiple feedback loops activate simultaneously, causing temperature jumps of 10-15 degrees Celsius within geologically short periods, maybe 10 million years. Life won't have time to adapt during these acceleration events. Now, you might be wondering, how do we know the AI is accurate? NASA validated Helios by having it predict known events in Earth's past. The AI successfully reconstructed the Paleocene-Eocene thermal maximum, the end Permian extinction, and other climate events with over 94% accuracy. If the model accurately predicts the past, there's strong reason to trust its predictions of the future. But Helios discovered something else. Something that could accelerate this entire timeline dramatically. And that brings us to the second twist. Everything I've told you so far describes the sun's gradual warming over billions of years. But NASA's AI identified a near-term threat that's far more immediate, and potentially civilization-ending. In 1859, a solar storm called the Carrington event hit Earth. It was the most powerful geomagnetic storm in recorded history. Telegraph systems worldwide failed. Operators received electric shocks. Auroras were visible at the equator. If an equivalent storm hit today, the consequences would be catastrophic. Our entire civilization runs on electricity. Power grids would overload and fail. Transformers would burn out. And we don't have spares. Recovery could take years. NASA's AI analyzed solar storm patterns and made a prediction that has governments quietly preparing. Within the next 50 years, there is a 12% probability of a Carrington-class or larger solar storm hitting Earth directly. 12% might not sound like much, but for context, that's roughly the same odds as flipping a coin and getting heads 3 times in a row. Would you bet civilization on those odds? It gets worse. Helios analyzed data from other sun-like stars and found that they occasionally produce superflares, events 100 to 1,000 times more powerful than anything in our historical record. The Kepler Space Telescope observed superflares on stars nearly identical to our Sun. The AI calculated that our Sun produces a superflare approximately once every 3,000 to 10,000 years. If a superflare hit Earth, the effects would be devastating. Massive radiation exposure, complete destruction of the ozone layer, electronics worldwide fried. The AI estimates such an event could cause billions of casualties and set human civilization back centuries. And here's the chilling part. There's geological evidence suggesting superflares have hit Earth before. Certain isotope spikes in tree rings and ice cores match the signature of extreme solar radiation events. In 775 CE, something bombarded Earth with intense radiation, possibly a solar superflare. If that event happened today, it would be catastrophic. And according to NASA's AI, we're statistically overdue for another one. Let's step back from the numbers and talk about what all of this really means. Because these predictions aren't just academic exercises. They define the ultimate fate of everything we've ever built. Humanity has existed for roughly 300,000 years. We've built cities, created art, developed technology, explored space. Every human achievement, every memory, every dream, every act of love and creativity has happened on this one fragile planet. And according to NASA's AI, this planet has an expiration date. The sun that gave us life will eventually take it away. So what can humanity do? The AI actually modeled several scenarios for long-term survival. Option 1. Geoengineering. We could potentially reflect more sunlight using orbital mirrors, stratospheric aerosols, or other technologies. The AI calculated that aggressive geoengineering could buy Earth an additional 500 million to 1 billion years of habitability. Option 2. Moving Earth. This sounds like science fiction, but it's theoretically possible. By carefully redirecting asteroids to pass near Earth over millions of years, we could gradually push our planet into a wider orbit, further from the warming sun. The AI modeled this scenario and found it technically feasible, though it would require a sustained effort spanning millions of years and carry enormous risks. Option 3. Leaving Earth entirely. Mars could be terraformed. Moons of Jupiter and Saturn could host colonies. Eventually, humanity could spread to other star systems entirely. NASA's AI calculated that if humanity becomes a multi-planetary species within the next 1,000 years, the probability of our civilization surviving until the sun's death drops from certain extinction to likely survival. Okay, I want to hear from you right now, because this video raises questions that don't have easy answers, and I genuinely want to know what you think. Question 1. Knowing that Earth has an expiration date, even if it's over 1 billion years away, does that change how you think about life? Does it make existence feel more precious, more meaningless? I'm genuinely curious. Question 2. If you could choose humanity's survival strategy, which would you pick? Geoengineering to extend Earth's life? Moving our planet to a safer orbit? Or abandoning Earth and becoming a spacefaring species? Drop your answers in the comments. I read every single response on these videos, and the discussions in this community are genuinely some of the most thoughtful on YouTube. Bonus question for the deep thinkers. The sun's death is certain. Should humanity invest resources now, today, in long-term survival planning? Or are there more pressing problems to solve first? There's no wrong answer here. But I want to see your reasoning. Let's have a real conversation about humanity's future in the comments. Now I know some of you are watching this and thinking, how can any AI predict what happens billions of years from now? That seems impossible. That's a fair question, and it deserves a serious answer. Here's the thing. We understand stellar evolution extremely well. We've observed millions of stars at different life stages. We can see what happens to sun-like stars as they age. The physics isn't speculative. It's some of the most well-established science we have. We know the sun will become a red giant. We know it's getting brighter. These aren't predictions. They're observations of physical processes we've confirmed across the universe. What NASA's AI does is synthesize all of this known physics with Earth-specific data to generate detailed timelines. The AI isn't guessing about stellar physics. It's calculating the precise consequences for our specific planet. And crucially, the AI provides uncertainty ranges. It doesn't claim to know exactly when oceans will boil. It provides probability distributions. That's honest science, not overconfidence. We've successfully predicted stellar behavior before. We knew when the star Betelgeuse would dim before it happened. We've predicted nova and supernova events. Solar physics isn't mysticism, it's engineering-grade science. The real question isn't whether these predictions are reliable. The question is what humanity does with this knowledge. But here's what keeps me thinking about this story long after the research is done. Because the death of Earth by solar expansion isn't the only way this story could end. NASA's AI modeled other scenarios too. What if a nearby supernova bathes Earth in radiation? What if a rogue planet disrupts our orbit? What if the superflare scenario happens next year instead of next millennium? And yet, there's something remarkable about the fact that we can even have this conversation. We're a species that evolved on one small planet, and we've developed the intelligence to predict the fate of stars. We've built machines that can see billions of years into the future. If we can predict our destruction, maybe we can prevent it. Maybe we can outsmart the universe itself. In my next video, I'm going to reveal what NASA's AI predicts happens after Earth dies. Because the sun's story doesn't end there, and neither does humanity's potential. What comes next is even more mind-bending than what I've shared today. The death of Earth is just the beginning of a much larger cosmic story, and you're going to want to see how it ends. Let's bring it all together. NASA's AI has given us the most detailed prediction ever made of Earth's ultimate fate. Within 500 million years, our oceans will begin evaporating. Within 1.1 billion years, Earth will be a sterile, scorched world. And within 5 billion years, the sun will expand to consume our planet entirely. But the AI also shows us paths to survival: geoengineering, orbital manipulation, interstellar expansion. The choice is ours. Not today, but across the coming centuries and millennia. If this video made you think, really think, about humanity's place in the cosmos, then do me a favor. Hit that like button, subscribe to the channel, turn on notifications, and share this video with someone who needs to have their perspective expanded. This channel is about the biggest questions in science. Where did we come from? Where are we going? What's possible for humanity's future? If those questions matter to you, then you belong in this community. I've left links to related videos on screen right now. One explores what happens when the sun actually dies. The other examines humanity's realistic timeline for becoming interstellar. We live on a temporary world, orbiting a temporary star, in a universe that's constantly changing. But we're also the first species on Earth that can understand our cosmic situation and potentially do something about it. Until next time, keep looking up. Our future is written in the stars, but we still get to hold the pen.